a lot of you are thinking to yourselves, well, how's he going to charge the batteries up? And what we're going to be doing is putting 3 6-amp diodes like these. I'm going to retrieve off this board, and they are going to go the positive side onto the normally open contacts on A relay, onto the normally open contacts of C relay, and onto the normally open contacts of E relay, which all go to the positive of these 3 packs. Now these diodes are rated at 6 amps. I've got them out of 6 amp battery charger. It's all to do with recycling again. So when the relays are switched over, it puts the 5-volt charge coming in onto this common line here and goes through the diodes into each individual pack. Each pack will draw its own amount of current and voltage it requires, and then it'll stop charging. Now, what we're going to use for our charging circuit, and why 5 volts and not 4.2? Well, these diodes, well, nearly all diodes except specialist diodes like Schottky, usually take about 0.6 of a volt. I'm sure there's going to be loads of electronic bods out there who are going to correct me on this, but it's just what I've surmised from my experiments. So if you take 0.6 away from 5, you end up with 4.4, I think it is. And allowing for discrepancies and not quite tuning the charger pot right, etc, etc, it'll get down to around about 4.2, which is good enough for me. Now what are we going to use? Because our charger needs to be 4 amps. Worst scenario. The batteries I've been charging have generally taken between 2 and 3 amps, and less sometimes, when I first put them online. But don't forget, these have been discharged and charged very unevenly, so they're going to be all over the place. But what I'm going to be using is 4 step-down converters. Now, the reason I'm using 4 is because the inputs will be parallel together, the outputs will be parallel together, but the outputs will have a diode in them, right? Schottky diodes to keep it down, and that should take out the odd bit to give us 4.2. Now, each one of these will be set to 4 volts. Each one of these is capable of 2 amps comfortably, 3 amps maximum. So when the battery is the cells are drawing the current that they need, it won't be all out of one converter or 2 or 3, it'll be spread out all 4. So if it asks for 4 amps, for example, each one will allow a single 1 amp charging current. Whether this is going to work or not, I'm not 100% certain, but until I try it, I don't know. Yes, I know I could calculate everything and look it up online and all the rest of it, but I'm a doer, not a theorist, and definitely not a mathematician. Okay, so that's our next video, to parallel these up, put the Schottky diodes on, and set these to give us 5 volts output. What I might do is 5 volts out each to start with, then put the diodes on and see exactly what we get at the point where it goes into the cells. Okay peeps,